Hello class 10th. In the last lecture, we have discussed about the work and its unit. Today we will discuss about power, its unit, energy and its form, especially kinetic energy and potential energy, relation between the momentum and the kinetic energy, and some numericals too. Starting with the first topic, power. For that, let us consider a scenario. I'm just giving a task to two students, student A and student B. I had given the task that get me the desk from the storeroom. And suppose A brought that desk in 10 seconds and B brought the same desk in 15 seconds. So tell me, who has done more work? If you're saying both are doing same work, A and B both are doing same work, then you are correct. But who is good between them, A or B? See, A is doing the work in 10 seconds and B in 15 seconds. So I think you are saying A has done a good work. Why? Because you are comparing with time. The one who has taken less time is doing good. So this leads to the new topic. If you are comparing the work done with time, means you are calculating power. This is the definition of power, that the rate of doing work is called power, or work upon time is also known as power. So power is equal to rate of doing work, or you can also say power is equal to work upon time. According to rate, it is divided by time, or with the symbol power is equal to W upon T. So this W upon T, we can split it into two parts. Work is equal to, we know that, force into displacement upon time. This displacement upon time, what is the displacement upon time? Which physical quantity? Velocity. So this F into velocity, this is power. So power has two equations, one this and second this. So we have seen the two equations of power. One, that power is equal to work upon time, and second, the power is equal to force into velocity. In examination, it is used to ask, write the expression for the power which includes the velocity. So remember, this equation is used to come in examination. Now let's talk about the units in the CGS system and in the SI system. So first of all, see the expression power is equal to work upon time, means the unit of power will be the ratio of unit of work and the unit of time. So unit of work is joule and unit of time is second in SI system. So its unit becomes joule per second or watt. Joule per second or watt. Simply you can say the unit of SI unit of power is watt. And same way in CGS system, the unit of work is erg and the unit of time remains same. So it becomes erg per second. So we have seen that, again see, the SI unit is watt and CGS unit is erg per second. Now let's move to the numerical section. I have seen the practice problem 1 and practice problem 2 of this chapter is quite so easy. So I am going for the practice problem 3. So see here, the practice problem 3 question number 2 is calculate the power of an electric pump in horsepower. I missed to inform you about the horsepower, so I'm informing you right here. This is the bigger unit of power, that 1 horsepower, that is called 1 HP, is equal to 746 watt. I missed to inform you about this, or in round figure it is 750 watt. If it is given that in the question 746, you will take 746, and if not given, so you can take any one, either 746 or 750 watt. So now move again. So we have to calculate the power, but in horsepower in this unit, and which can lift 2000 meter cube of water from a depth of 20 meter in 25 minutes, given that G is equal to 10 meter per second square and the 1 meter cube of water is equal to 10 to the power 3 kilogram. This is the mass given. So let's first write what is given here. So see here, 1 meter cube water has weight of 10 to the power has a mass of 10 to the power 3 kg. If it is 1 meter cube, so 10 to the power 3. If it is 2000 meter cube, so 2000 multiplied by 10 to the power 3. Again, see if you're not understanding. 1 meter cube is equal to 10 to the power 3 kg. 2000 meter cube is equal to 2000 multiplied by 10 to the power 3. See here I have written m is equal to 10 to the power 3 to 2000 kg. It becomes the mass. Second thing, the value of depth. This will be the height. So a height is equal to 20 meters like this. And the next, in 25 minutes, this is the time. You have to write in second. So writing that t is equal to 25 minutes, or 25 into 60, this gives 1500 second. And the value of g given in the question, that is 10 meter per second square. What is the question in the calculate the power? I have to convert into horsepower, but the motto is to calculate power. So we have the equation power is equal to work upon time. First let's try that. Power is equal to work upon time, that is equal to force into displacement upon time. Here the force is the weight of that water, and the displacement is the height, or you can say depth, and time t. Let's put all the value. On putting all the values, mass 2000 into 10 power 3, value of g 10, height 20 meter, and the time 1500. On solving you will get the power 2.66 into 10 to the power 5 watt, but this is in watt. We have to convert into horsepower. So 1 horsepower is equal to 746, but take the round figure because nothing given in the question. I'm taking 1 horsepower is equal to 750. So I will divide with 750 to convert this into horsepower. Let's see. That gives you this value. HP is equal to 0.6 upon 750 into 10 power 5 HP. On further solving, you will get 355.55 horsepower. This is the final answer. And for the practice problem 4, in the question there must be written that some machine is something percent efficient. Whenever this type of question is there, don't calculate the percentage of the power. First of all, convert that power into the work by multiplying with time, because power is equal to work upon time, so work is equal to power into time. Then calculate the percentage value of the work. Suppose the machine is 60% efficient, then do 60% of the work done, then calculate. For that, let's see this question. So this is practice problem 4, question number 1. An electric pump is 60% efficient and is rated 2 horsepower. Calculate the maximum amount of water that it can lift through a height of 5 meter in 40 seconds. The value of G is given, and see the value of 1 horsepower is given. So first of all, let's write what is given. That is power given first, 2 horsepower. So power is equal to 2 horsepower is equal to 2 into 1 horsepower value gives 1500 watt. This is power given. Then calculate the maximum amount of water it can lift. Amount of water means asking about the value of mass of water, that is question mark. And through a height, h is given 5 meter, h is equal to 5 meter in 40 second. Time is given that 40 second. G 10 meter per second square, and this has been taken here. So again, what I said, if the efficiency is given, the efficiency has a symbol you don't know, but you come to know here now. The efficiency has symbol this one. It is called eta. So efficiency eta is equal to 60%. So what I told you, first find the work done, then convert into its percentage value. So we know that work done is equal to power into time. So what is power? 1500. Time 40 seconds. 15 into 4, 60, and 000. So it is 60,000. Work has unit of joule. So now if this is 60% efficient, so you will write here since pump is 60% efficient, so its useful work is equal to 60% of 60,000. This one, let's calculate. So here you will get useful work is equal to 36,000. That pump can do the work of 60,000, but the efficiency is only 60%. So 60% of 60,000 is 36,000 joule only. Okay, so this is work. So now useful work will be equal to force and displacement again. Again, useful work is equal to force is equal to mg, the weight of water or anything, the height. So useful work is equal to mgh or mg into s. Let's put the value. It will lead you here. It will lead you here now on solving further. It will lead you the mass 720 kg. This is the final answer. Now our next topic is energy. Energy and work are like two faces of a coin. When there will be head, there is tail, and when there will be tail, there is a head. Means if you have the energy, then you can do the work, and if you are doing work, means you are having energy. So energy is the capacity of doing work. So it is having a different of branches and different of units to be calculated. First, the calorie. What is calorie? When 1 gram of water, remember this, 1 gram of water is going to be heated. Calculate the rise in degree. When there is a rise of 1 degree Celsius in the temperature of water, then it means the supply has given how much energy? 1 calorie to the water. Instead of that, if the water is 1 kilo, then the energy supplied to just raise the 1 degree Celsius temperature, so that energy is given by the source is 1 kilocalorie. Second one is kilowatt hour. When power of 1 kilowatt flows through the circuit through a conductor for 1 hour, then the energy spent, or you can say energy flowed in the wire, is 1 kilowatt hour, and 1 kilowatt hour is equal to 3.6 megajoule. And the last one is the energy of electron. When one electron moves through electric circuit between the potential difference of 1 volt, then it means the electron has energy to move through the circuit is 1 electron volt. So whatever you have listened, that 1 calorie is equal to 4.2 joule. Second, 1 kilowatt hour is equal to 3.6 megajoule. And the third one, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. These all units will be in detail in further chapters. Only you have to remember the relation. What is the relation between the units of different branches to the SI unit? And many more kind of energy like mechanical energy, heat energy, sound energy, chemical energy, vibrational energy, and many more. But we are going through detail about the kinetic energy. First of all, what is the definition of kinetic energy? Kinetic energy defines that when the object is in motion, the energy possessed by the body or that object is kinetic energy. Or you can say the general definition, the energy possessed by the body by virtue of its motion, that's kinetic energy. Let's see further detail. If you go through detail about the kinetic energy, so kinetic energy is still divided into three parts. One, translational kinetic energy. Second, rotational kinetic energy. And the third, vibrational kinetic energy. Translatory means if the object is moving in a straight line. Rotatory means if the body is moving about any point. And vibrational means the object that you are saying that every molecule means either it is solid, liquid or gas, every matter vibrates about its mean position. Solid has very light vibration, liquid has little more, while the gas has little larger than the other two. So that vibrational kinetic energy. But we are going to see the kinetic energy in mathematical form first. So what is the mathematical equation for the kinetic energy? Let's prove that. See the mathematical expression of kinetic energy. For that, let's consider an object of mass m. This is the mass m of the body, and let this object is moving in this direction. The object is moving in this direction, so I'm considering the initial velocity that v. It doesn't mean that this is final velocity. The initial velocity of the object means the body is already in motion. It is already in motion, and someone is going to stop it. Suppose someone is stopping with the force F. This is being retarded. This is being to stop with this force. The force is directed in this direction. The object is moving in this direction. If this force will continue to stop this body, after some time it will come to rest. And see, let's suppose due to the retarding force, the object was moving displacement S and come to rest. And listen now, Whatever the force is applied on this body to stop it, someone has done work. This force and this is displacement. So whatever work is done to stop this body should be equal to the energy possessed by the body. Means, in other words, we can say this body was having energy and now no energy. So this energy was what was converted into the work done. So who has done the work? This force. So the whatever the energy was possessed by the body is equal to the work done by this. So we will calculate here work done. We will calculate here work done, and automatically the energy will come to in this form. So let's see first. So we can say the work done will be equal to energy of body, and that energy will be the kinetic energy. So we can say the kinetic energy here will be equal to the work done, that is F into S, and F is equal to mass into acceleration because this is in linear motion, and the S is given, mass is given. The motto is to find this acceleration. For this let's use the third equation of motion, that is v square is equal to u square minus 2s, minus because here it is retarding. And what is the final velocity? 0. What is the initial velocity? V. Let's put that first. Don't go with the figures. This is the v, final velocity was 0. This is the u, was initial velocity is v. So see here, and let's find the v square. A is equal to, on solving you got the value of a, that is v square upon 2s. Let's put this value of a in this equation. Say this is the equation 1. On putting that, let's see. So on putting, C mass is here, instead of a, the value of this is here, and s as it is. So you can say s and s will be cancelled. On cancelling it, what you will have? You will have mv square upon 2, or kinetic energy is equal to half mv square. This is true. So our next topic is the relation between the kinetic energy and the momentum. So let's see. So let's prove the relation between the kinetic energy and momentum. Again, let a body of mass m moving in this direction with velocity v. As the object is having velocity and the mass, means it is already possessing kinetic energy. And I think you know the momentum, it is the product of mass and velocity. Using that, I'm writing first the momentum of the object. So this is the relation between the momentum and mass velocity. So what we have to find? We have to find the relation between this momentum and kinetic energy. Let's write the expression for the kinetic energy also. Kinetic energy is equal to half mv square. So if suppose the value of v from this equation, if we put the value of v from this equation to this equation, I think we can obtain the equation. So first of all, from here, v is equal to p by m, making this equation 1 and this equation 2. Put the value of equation 1 in equation 2. Let's see what we have. See here, the kinetic energy is equal to 1 by 2 half m v square. Here it was with v square, and instead of v square, I'm writing what? P by m. What will further here? See here, kinetic energy is equal to half m v square upon m square. 1 m will be cancelled here. So what remaining? Let's see. K is equal to p square upon 2m, or p square is equal to 2m ke, or finally you are getting the p momentum is equal to under root 2 mk. This is the relation between the momentum and the kinetic energy. That's done. Now let's talk about the potential energy. That it defines that the energy possessed by the body by virtue of its position is called potential energy. Still, this potential energy is divided into two parts. One, gravitational potential energy, and the elastic potential energy. So gravitational defined as the energy possessed by body by virtue of its position, and elastic potential says the energy possessed by body by virtue of its configuration. So what is the difference between them? First, understand this. Gravitational potential means if any object, suppose this object, if I'm raising this up, so if the height is raised by h, so the potential energy increase, that is mgh. We will see in the notes also. And the elastic potential energy says the energy possessed by the body by virtue of its position. So suppose we are winding up any toy car. So when you are winding up, so the spring inside that is compressed. So that compressed spring is having potential energy, but elastic potential energy, like rubber band. If I'm stretching a rubber band, that is rubber band wants to come back, want to regain its shape, so that because of elastic potential energy. So let's first see the expression for the potential energy. Like we have proved in the kinetic energy, we will do the same in potential energy. For that, let's suppose a mass, suppose a mass on ground and it is raised to height h. See, this object is raised to this height h. The acceleration due to gravity always acts in this direction. So what is the weight here? Means what we have work done in moving this object from here to here. Let's calculate, because that work will be the potential energy. So we can say the potential energy here will be work done, and the work done will be what? Force into displacement always. And what is the force here? Force is the weight of the object. Force is equal to mass into acceleration. And what is the displacement? See, from here to here it is displaced h. So we got the expression for the potential energy, that is mgh. That's it. Now let's move to the numerical section. See here the question, practice problem 5, question number 2. A catapult throws a stone of mass 0.1 kg with a velocity of 30 meter per second. If 25% of potential energy of elastic band is wasted during transmission, find magnitude of potential energy. See here, the catapult is having the energy, kinetic energy. In the stone is having the kinetic energy. This mass is given, this velocity is given. So you can calculate the kinetic energy of the stone thrown by the catapult, and asking about the potential energy in the catapult. But we are having only the energy in stone, that is kinetic energy. So we can consider, let the potential energy of the elastic band, or you can say catapult, was PE. And 25% of elastic band is wasted. How much wasted? 25%. As question says, 25% of energy is wasted, so it means 75% of energy would have been transmitted. So 75% kiska energy, to whose energy? 75% of potential energy is transmitted and is converted into what? The kinetic energy. So we can write here, see, 75% of potential energy is equal to kinetic energy in stone. What happened? 25%? 25% is wasted. Remaining 75%. 75% of potential energy is transmitted the energy to the stone through the catapult. So the 75% of potential energy is equal to kinetic energy in stone. Let's fill all the values. See, the mass of stone was 0.1 kg and velocity 30 meter per second square. Sorry, 30 meter per second. So 30 is whole square. So PE is equal to 1 by 2, 0.1, 30 into 30, and this is going to that side, becomes 100 upon 75. On solving, you will get potential energy is equal to 60 joule. So 60 joule was given to the catapult, out of which 25% lost, remaining 75% converted into the kinetic energy in the stone. This was the question. Now this is practice problem 8, question number 2. The question says, in the adjacent diagram, the mass of the object is 5 kg, means this object is of 5 kg mass. The question is, first calculate force of gravity on this. Force of gravity, you know that force of gravity will act in this direction, and the force of gravity in this direction is equal to, known as the weight of the object. So the solution for the A, that force of gravity is equal to W, means weight, and weight is equal to mg. Let's fill the value in the question given. Mass of that 5 kg object, 5, value of g is given, so 5 into 10, 50. So weight become 50 newton. So first part is done. Second part, work done along the inclined plane, means while pulling this object from here to here, what is the work done? In this case, while pulling him from here to here, the applied force is 30 newton and the displacement is 5 meter. So in this case, the work done is equal to force into displacement. We will take this force because asking in this direction, work done along inclined plane. So you will take force 30 newton and displacement 5 meters. So let's do that. So work done along the inclined plane, W is equal to F into H. So force 30 Newton, displacement 5, 150 Newton meter, or finally 150 Joule. And the last part, work done against gravity, means in moving the object from here to here. Against gravity, it is moving from here to here. Against gravity, the object is moving from here to this height. So force acting downward, that is weight, and the displacement is upward direction. So what is the upward displacement when the object is moving from here to here? What is the upward displacement mean? What is BC? Not given. So using Pythagoras theorem, we can calculate. Using Pythagoras theorem, if this is 4, this is 5, I think you can calculate this value will come to 3 meter. I'm not going to use Pythagoras theorem. You can, I think, find that. If this is 4, this is 5, so this one will be 3 meter. So work done against gravity means the weight acting downward and the vertical displacement. It is moving from here to here, but vertical displacement is 3 meter. So let's write that. So work against gravity, W is equal to F into S. F is here weight, mg, and the height is h. We have already calculated in the first part that mg was 50 Newton and the height was 3 meter. So it comes to 150 Joule again. In the question it is given 90, that is incorrect. Okay. So we have seen all the numericals and the topics, and I hope you will solve all the numerical and inform me. And in the next class, we will talk about the law of conservation of energy and further topics and few numericals also. So till then, thank you all.